Good morning, students. In the previous class, we discussed about the special methods of preparation of aldehydes and the ketones. Ketones ಮತ್ತೆ aldehydes ನ ಯಾವ ತರ ಸ್ಪೆಷಲ್ ಮೆಥಡ್ಸ್ ಅಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತಾರೆ ಅಂದ್ರೆ ನೇಮ್ಡ್ ರಿಯಾಕ್ಷನ್ಸ್ ಅಲ್ಲಿ ಯಾವ ತರ ಪ್ರಿಪೇರ್ ಮಾಡ್ತೀವಿ ಅನ್ನೋದನ್ನ ಪ್ರೀವಿಯಸ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ತಿಳ್ಕೊಂಡ್ವಿ. In this class, we are going to be discussing about the properties of these aldehydes and ketones. Properties means we will take both the physical properties and the chemical properties. First, we are going to be discussing about the physical properties of aldehydes and ketones. That is about the physical properties. When it comes to the physical properties of aldehydes and the ketones, here the most of the aldehydes are liquids at room temperature. Most of the aldehydes are liquids at room temperature, and the lower members of the ketones are the colorless liquids, and the higher member of the ketones are colorless solids. Illenagirutte aldehydes, most of the aldehydes liquids ಆಗಿರುತ್ತೆ room temperature ಅಲ್ಲಿ. ಜೊತೆಗೆ ketones lower member ketones colorless liquids ಆಗಿರುತ್ತೆ. ಮತ್ತೆ ಅದೇ higher members ketones that in the colorless solids ಆಗಿರುತ್ತೆ ಅಂತ ಹೇಳ್ತಾರೆ. It's going to be colorless solids. This is about the state of this aldehydes and the ketones. State ಅಂದ್ರೆ physical ಅಲ್ಲಿ ನಾವು ಏನು ನೋಡ್ತೀವಿ, boiling point, odor, then state, like that we are going to be discussing. Now next is the boiling point of these aldehydes and ketones are higher than the comparable hydrocarbons of the molar masses. ಅಂದರೆ ಇಲ್ಲಿ ಸೇಮ್ molar mass ಇರುವಂಥ ಹೈಡ್ರೋಕಾರ್ಬನ್ಸ್ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಏನಾಗಿರುತ್ತೆ, aldehydes ketones ಜಾಸ್ತಿ ಇರುತ್ತೆ ಅಂತ ಹೇಳ್ತಾರೆ. Means it is the boiling point of the aldehydes and ketones are higher than the hydrocarbons of comparable molar masses. ಯಾಕೆ ಆಗಿರುತ್ತೆ, ಯಾಕೆ ಜಾಸ್ತಿ ಆಗುತ್ತೆ? Because of the dipole-dipole interaction. The reason behind this is dipole-dipole interaction. These are very important in alcohols or maybe alcohols or aldehydes. Aldehydes ಆಗಿರಲಿ alcohols ಆಗಿರಲಿ, ಇದು boiling point related to this interaction. It's very important. They are going to be asking the examination for the 1 mark. Why the boiling point of that is aldehydes are the higher than the corresponding hydrocarbons, that is corresponding hydrocarbons of the comparable molar masses, because due to the dipole-dipole interactions. Then next, dipole-dipole interactions are weaker than the intermolecular hydrogen bonding in the alcohols. Therefore, the boiling point of the aldehydes and the ketones are lower than the alcohols of comparable molar masses. ಇಲ್ಲೇನಾಗಿದೆ, aldehydes boiling point ಹೈಡ್ರೋಕಾರ್ಬನ್ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ಜಾಸ್ತಿ ಇದೆ, ಅದೇ ಆಲ್ಕೋಹಾಲ್ಸ್ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ಕಮ್ಮಿ ಇದೆ. ಆಲ್ಕೋಹಾಲ್ಸ್ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ಕಮ್ಮಿ ಇದೆ. ಇಟ್ಸ್ ಬಿಕಾಸ್ ಯಾಕೆ ಕಮ್ಮಿ ಇದೆ ಆಲ್ಕೋಹಾಲ್ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ಅಂದರೆ ಇಟ್ಸ್ ಬಿಕಾಸ್ ಆಫ್ that is a dipole-dipole interaction is weaker in the aldehydes. Therefore, it is a less that is weaker in the that is about the boiling point in the aldehydes. The next these when it comes to that the next point, then the soluble, that is aldehydes, that is the lower members of aldehydes ketones are soluble in, that is about the soluble in the water, but higher members are not soluble. These are readily soluble in organic solvent, This is about the physical properties of the that is aldehydes and the ketones. ಏನು ಫಸ್ಟ್ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ದು that is state ಅಂದರೆ aldehydes ಇಲ್ಲ, almost all aldehydes are in the liquid state, and the ketones, lower members ketones are that is the liquids, and higher members are solids. Then boiling point of aldehydes and ketones higher than the hydrocarbons of comparable molar masses due to dipole-dipole interaction. Then dipole-dipole interaction is weaker than the alcohols of comparable molar masses. Therefore, the boiling point of aldehydes is less than the alcohols of comparable molar mass, and the aldehydes and the ketones, these are soluble in the water, lower members, but higher members are not soluble in the water. This is about the physical properties. The next we will discuss about the chemical properties of aldehydes and the ketones. Aldehydes and the ketones. When it comes to the chemical properties of aldehydes and the ketones, chemical properties. First, we will discuss about the nucleophilic substitution and nucleophilic addition reactions. And we are going to be discussing about the nucleophilic substitution, addition reactions. Nucleophilic addition reactions. In this, that is aldehydes, ketones undergoes the nucleophilic addition reactions because that is the carbonyl groups means that it contains the oxygen. The oxygen is electronegative element, more electronegative element. This will get the partial negative charge and the carbon gets the partial positive charge. Therefore, the attack of the nucleophile to the carbon, it is very easy. Means that is the due to the high electronegativity of the oxygen atom, that is carbonyl group barkondivi anta. Suppose if you are going to be taken the carbonyl group, in this oxygen is more electronegative. Therefore, this will get the partial negative charge and this will get the partial positive charge. Therefore, the attack of the nucleophile, that is the attack of the nucleophile to the carbon, is very easy. Therefore, these aldehydes and the ketones undergoes the nucleophilic addition reaction easily. We will come to that mechanism of nucleophilic substitution. When it comes to that mechanism of nucleophilic addition reaction. This undergoes in the two steps. That is the mechanism of nucleophilic addition reaction undergoes in the two steps. In the step 1, what happened? The step 1, that is attack of nucleophile. Attack of nucleophile. Yeah, the attack of the nucleophile means here nucleophile is going to be attacks the carbon because the carbon gets the partial positive charge due to the high electronegativity of the oxygen atom. If suppose if you are going to be taken the attack of the, that is the nucleophile, to the carbon, then this bond, that is pi pair of electrons shift towards the oxygen atom. It is going to be formed a tetrahedral, that is oxyanion. It is going to be formed that tetrahedral oxyanion, that is the O minus, that is the, this is about the tetrahedral oxy, and intermediate is going to be formed. This in the second step, this is going to be oxyion. It's going to be attacks the proton. Otherwise, any other electrophile, it's going to be use the product. In the step 2, what happens? That is the in step 2, what happens? That is the what we are going to get intermediate product. For this intermediate product, be get that is attack of the that is the proton, attack of the proton. We are going to be get that the respective product we are going to be get. This is about the nucleophilic, that is mechanism of nucleophilic addition reaction. This is going to be takes place in the two steps. ಏನಾಗುತ್ತೆ ಫಸ್ಟ್ ಸ್ಟೆಪ್ ಅಲ್ಲಿ ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ ಅಟ್ಯಾಕ್ ಆಗುತ್ತೆ. ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ ಅಟ್ಯಾಕ್ ಆಗಿ ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಟೆಟ್ರಾಹೆಡ್ರಲ್ ಇರುವಂಥ ಒಂದು ಶೇಪಲ್ಲಿ ಇರುವಂಥ ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಕಾಂಪೌಂಡ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. ದಟ್ ವಿ ಕಾಲ್ಡ್ ಆಸ್ ಆಕ್ಸಿಯಾನೈನ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. ಆಕ್ಸಿಯಾನೈನ್ ಕಾಂಪೌಂಡ್. ದಿಸ್ ಅಟ್ಯಾಕ್ಸ್ ದಿ proton. It's going to be use the product. It's going to be use the product. Like this only, these nucleophilic addition reactions, the examples we'll discuss. This is about the general representation of the nucleophilic addition reaction. Now we'll discuss about the addition of the, that is hydrogen cyanide to the, that is carbonyl compound. We'll discuss now. Now we'll discuss about the addition reactions. This is about the addition reactions. These aldehydes undergoes the nucleophilic addition reaction easily compared to the, that is the ketones, because of the two factors. This is responsible for the two factors. The one is electron releasing capacity and also the steric effect, the steric effect. These aldehydes undergoes the nucleophilic addition reaction easily compared to the ketones. Now we will discuss about the addition reactions. In that, the first one we are going to be discussing about the addition with the hydrogen cyanide. That is addition with the hydrogen cyanide. Means the hydrogen cyanide, first it is going to be catalyzed. The addition of the hydrogen cyanide to the carbonyl compounds, either aldehydes or ketones, it is catalyzed by the base. It is catalyzed by the base. Therefore, we are going to be taking the reaction, that is the HCN, hydrogen cyanide, that is a base. We are going to be taken as a base. At that time, it is going to be formed that is the Cn minus, then plus H2O. The attack of nucleophile formed here. Nucleophile is going to be formed. Then attack of these nucleophile. Attack of this nucleophile to the carbon. Then we are going to be get the intermediate cyanohydrine product. That is intermediate cyanohydrine product. That we are going to be mentioned as, that is the Cn, then O minus. This is about the intermediate product. That is intermediate we are going to be get. For this, this undergoes the hydrolysis. We are going to be get the product, that is cyanohydrine. That is the respective cyanohydrine we are going to be get. That is the Cn, then OH. Respective cyanohydrine is going to be formed. This is about the general. ಇಲ್ಲಿ ಹಾಲಿಡೇಸ್ ಅಂತ ತಗೊಂಡಿಲ್ಲ ಅಥವಾ ಕೀಟೋನ್ಸ್ ಅಂತ ತಗೊಂಡಿಲ್ಲ, ಬೋತ್ ಜನರಲ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ನಂತದ್ದು. ಅದೇ ಪರ್ಟಿಕ್ಯುಲರ್ ಆಗಿ ಒಂದು ಹಾಲಿಡೇಟ್ ತಗೊಂಡಾಗ ಯಾವ ತರ ಫಾರ್ಮ್ ಆಗುತ್ತೆ ಅಂತ ನೋಡೋಣ. ದಿಸ್ ಅಬೌಟ್ ದಿ ಹೈಡ್ರೋಲೈಸ್ಡ್. We are going to get this. ಅಂದ್ರೆ ಇನ್ನ ಅಸಿಟಾಲ್ಡಿಹೈಡ್. ಫಸ್ಟ್ ವಿಲ್ ಟೇಕ್ an example for this. That is aldehyde ತಗೊಂಡು. aldehyde ಗೆ ಎಕ್ಸಾಂಪಲ್ ಫಸ್ಟ್ ಅಸಿಟಾಲ್ಡಿಹೈಡ್ ತಗೊಂಡು. ಅಸಿಟಾಲ್ಡಿಹೈಡ್ ಏನು ಫಾರ್ಮುಲಾ? That is going to be CH3CHO. That is about the formula for the acetaldehyde with addition of the acetaldehyde. That is one we are going to be taken with the acetaldehyde. Addition of CN to the acetaldehyde. The acetaldehyde ಏನು ಬರ್ಕೊಂತೀವಿ? That is the CH3C double bond O. That is addition of the hydrogen cyanide. We are going to be get the intermediate product. We are going to be get that intermediate product. ಏನು ಬರುತ್ತೆ? CH3 C H then O minus O H OH then Cn. We are going to be get this on hydrolysis. Again hydrolysis, we are going to be get that the lactic acid, that is CH3 CH OH then COOH lactic acid. We are going to be get the lactic acid. Illenagtade acetaldehyde reacts with the HN. It is going to be form the acetaldehyde cyanohydrin. The name of this compound is acetaldehyde cyanohydrin. This on hydrolysis we will get that lactic acid here. Means I'll write that. ಇಲ್ಲೇನಾಗ್ತದೆ ಅಸಿಟಾಲ್ಡೇಟ್ ಬೇಕಾದ್ರೆ ಇಂಗ್ಲಿಷ್ ಬರೀತೀನಿ ನೋಡಿ. ದಟ್ ಈಸ್ ದಿ ಅಸಿಟಾಲ್ಡೇಟ್ CH3 CH double bond O. This is about the name of this compound is acetaldehyde. Acetaldehyde. This acetaldehyde reacts with the hydrogen cyanide, HCl, hydrogen cyanide. It's going to be formed that intermediate compound that about the CH, then CH3, then OH, then Cl. Name of this compound is acetaldehyde cyanohydrin. The name of this compound is acetaldehyde cyanohydrin. This on hydrolysis, we are going to be get that is 2O. We are going to be get that is the lactic acid, that is CH OH COOH. This is about the lactic acid. Like this only. This also reacts that is a hydrogen cyanide also undergoes the nucleophilic substitution reaction. Acetone. Here acetaldehyde ಆಯಿತು. ಇಲ್ಲಿ we will take that next example, that is acetone, that is C double bond O CH3. This addition of the hydrogen, the name of this compound is acetone. That is addition of the hydrogen cyanide to this. We are going to be get that. That is the acetone cyanohydrin. That is the COH CH3 Cl. The name of this compound is, that is acetone cyanohydrin. This about the addition of the hydrogen cyanide.